thing that happened. If our computer player and a human player are going to be interchangeable, they have to have the same methods available to them within the game. So we're going to add to our human player a choose secret word. This will ask our human player for the length of the word after they've chosen their word. A reveal. This is going to ask the human player to just tell us their word, and now we have to come up with this check guess. So this was the old one from the computer. So ours is going to say this character was guessed, and now we have to get some kind of feedback, right? Like what character, like enter what character numbers they were, right? Mm-hmm. So okay, let's see the best way to explain it. So we'll say please enter the index, or not. Well, a regular player probably should know what an index is, right? But we'll say please enter the position of the character. And then if the character appears more than once, separate by a comma. Right? Seems fair. And I'm going to assume that the person's going to think, oh, well, we can put an example. We don't need this. If your word is hello and the guess is L, your response should look like 1, 2, 3, 3, 4. Right? These are too high. We'll have to do a little bit of math back. So then we'll say let guess, and then we'll get our read line dot question. I'm just going to leave that empty so they can type it in. And now our guess is going to be some string separated, right? Mm-hmm. So we have to update that. So we have to say guess.split, and I'm going to go ahead and split on the comma. I'm going to map over it and say element is going to be number at element, because I want every number. I don't want a string, right? I want it to each be the element as a number, and I'm also going to -1 to get it to be the right spot in the indice. So I'm going to say let output result. And I'm just going to return result. Okay. We should probably test this. So we're going to go let Corey equal new human player, send Corey, and we'll say console.log Corey dot choose secret word, so make sure that works. Instead of choose secret word, we'll have reveal, make sure that works, and we'll have position, what do we call it? Check guess. And we should pass in a guess, we'll pass in, let's say, L. And we'll pretend our word is hello. Okay? So we'll go back to our game. I can make this a little bigger. Close this for now. And let's try it. So we'll say node at human player. And the length of your word. Okay, that looks good. So HELL 5. Okay, so realized it was 5. That's good. It was a number. What was your word? Hello. Please enter the position of the character. If the character appears more than once, separate by a comma. If your word is hello and the guess is L, your response should look like that, 3, 4. So it knew what our word was. and it turned that into 2, 3, which are the correct indices for hello. So it's working. Everything we wrote is working. Any questions on this so far?
Why do we need in check guess?
Also, by the way, I just want to make this to lowercase. In the check, yes, yeah.
Why do we need to console log those statements? Like if the character appears more than once, separate by comma.
I'm just keeping my user instructions.
Oh, okay.
Because I'm going to assume, like, if you downloaded this game, you won't know the way you will because you were with me while we coded it. But if you weren't with me, you would have no idea what the input's supposed to look like. I'm telling you, like, hey, if I give you an L, like, it should come back looking like this.
Okay.
It might not be the most clear example, right? There's probably a better way. Right? I could have instructions at the very beginning of the game or something like that too. But this is just a small little instruction. So, assuming this is correct, we can go back to our game and try it with 2 human players. So now we'll say Robo is instead human player, and we'll name him Robo still. And we'll go ahead and run our node.
So what would the new game be with?
The same. We just changed this from computer player to human player. So now the human is going to be the guesser, and the human is going to be the ref.
Okay.
So we'll have 2 human players. So enter the length. So it'd be good for it to say the name, right? I'm going to go ahead and add that because otherwise it's a little confusing. So I'm just going to say this dot name. Okay. And I'm going to add a space here. Okay. Let's try again. Sorry about that. Okay. So it says Robo, enter the length of your word. So what should Robo's word be?
Surprise. 8.
8. Okay. This year you're going to manage Robo.
Okay.
So this would be a good thing to add. You can see like it's kind of unclear who's who. So it would be a good idea in our game to go ahead and like say like this dot guesser dot name, whatever. Like enter the length of your word, Robo, and then this says let us guess so far. Please enter a character. Well, I guess the other person knows this is their role. So I don't know. You could change it, right? So you said surprise. I'm going to go ahead and guess E. And it's going to say, if your word is hello and the output is L, your response should look like this. So you should tell me where it is. So there is no, there is an E in surprise.
Yeah. The 8.
Well, an 8?
Yeah.
It's the 8th letter, right?
Mm-hmm.
Are we sure?
So it will be the 7th index?
Yeah, so that will come back and it will look like that. Is that correct?
Yeah.
Okay. I thought it was surprised. Okay, good. Okay, so the game works. We can see that it's working with 2 human players. Things to note, right? We could make this a little bit more clear on who's doing what by using their name. Result should be like what happens if it's okay, so this is something we should check. What if they enter nothing? Please enter a character and okay, I guess H, and we say it's not in there. Okay, so it still handled it. That's good. So the game still works, right? The instructions aren't perfectly clear, but it still works. Okay, so now we can play with 2 human players. We can play with a human guesser and a computer ref. Now let's add a computer guesser, right? Okay, so what do we have for our human guesser? We have a get move and a display board, and these were the only unique things, right? Display board and get move that computer doesn't have. So we can go ahead and add that. So we need a display board that takes in a board, and we need a get move. Okay. Do we want to make our computer smart or stupid?
Smart.
Oh man, tough crowd today. Wow, okay, I like it. So, if that's the case, our computer, how do we want to do this? This is a lot of code. Oh, that's not too bad. Our computer should probably keep track of guesses that it's made. Like, it needs that itself. So, I'm going to go ahead and say, like, this dot guesses made. And I'm going to go make that a set again. And we probably need the board. Because our display board doesn't really need to do much, but it should create its own little board that we can look at. Does that make sense? Because like, it doesn't need to print anything to the screen, but it needs to have access. Does that make sense?
Board.
Thank you.
It doesn't need to print anything.
Well, like our human player and our display board, we needed to visually see this on the screen. But the computer doesn't need to do that at all.
No.
Right. The computer just needs to update its own board. And so that it knows the spaces and whatnot. It will be able to see things. So then its get move, it's got to be smart. So the first thing it's going to do is it's going to update its dictionary to be words that are only the length of this board. Right? So we're going to say this dot dictionary dot equals this dot dictionary dot filter words of words dot length equal to this dot board dot length, and we can invoke that because that was a method we have on our board. Okay. So now
Equals what? Oh, this dot board. Oh, that was my other question. How come we have to invoke again?
Okay. So board, the instance of board looks like this, right? It's a whole class.
Right.
It's this whole constructor. So it's got a property called board inside of it, which is this array, and then it's got all these methods attached to it. So naturally, board as the object, the instance, doesn't have a length property. You would have to say board.length. Because board as in the class instance, board.length. But that's kind of ugly.
Yeah.
And it's kind of should be against the rules. In some languages, it is. It's like some languages it says like, oh, you can't, like you should not be able to see that. Those things are private. And so we have to create something that allows us to access those instead of, so we can't manipulate this. We shouldn't be able to we really shouldn't be able to manipulate this like from another class, not without accessing it correctly. That's called like encapsulation. And so here we're like, if we want the length, we have to call a method that gives us the length. And instead of touching the insides of it.
Okay.
So with that in mind, we go back to our computer player and we filter down all the words that are that length. And the next thing we need to do is, well, let's think about it. Let's think about it. We need to filter out any word that doesn't how are we gonna do this? Right, we're gonna get information back on this board, and we're keeping track of our guesses that we make. Okay, so we need only the words that could be still within the board, depending on really how smart we want to go.
Okay, question.
Yeah.
Given this structure, is say if I choose a word that's not in the original array, will the computer
In the
say-
dictionary?
Yeah.
We'll lose.
Okay.
Most likely we will.
Gotcha.
lose.
Okay.
Right? We can also have our alphabet. Or like when we don't get a correct answer, we'll have to resort to this. I think we'll need that. I'm trying to think. This is the hardest part. So okay, I guess we'll do filter again. Let's see. Let possible words equal an empty array. And then I'm gonna iterate.
Could it filter based on whether you have the letters in the secret word?
Well, that's what we're gonna need to do, yeah. But we don't know the secret word.
Okay.
So we'll have to say if we could have missed, like misses in here, then we wouldn't know. How are we gonna do this? I've done it before. Just it's kind of a pain in the butt. Reference might want to work. Okay. Instead of I'm gonna use some stuff that I've written in the past, kind of. So we can say hey, let missed. These are gonna be our missed guesses. Now I'm gonna call that a new set as well. And I'm gonna add all of our guess characters into it. Guesses made. Okay. So then we can iterate. Okay.
What are the periods for before this guy has?
Yeah, so that's called a spread operator. So what it's doing is it's taking our current set and just turning it into an array, essentially. This is just going to help us with this. So I'm going to go ahead and say for let I equal 0. So while I is less than our this dot board dot length. I plus plus. Okay. And then we can say we can get our character. So let stop board or let character is equal to this dot board dot get at I. So we're gonna iterate through our board and we're gonna get the character at that board. Okay, so if the character wait, how's this work? Miss, delete. Hang on. Okay. I have some old notes that I'm referring to. Okay, so if our character does not equal that underscore, you can say like, hey, if our character is not equal to this underscore, right? So that means we have a real character here. Then we can delete this from mist. Mist.delete character. Because that means that wasn't one of our missed guesses. Does that make sense?
Right.
So right here, we created this variable called mist, and we made this essentially be the exact same as our guesses made. Our mist is identical to our guesses made, and then we're iterating through our characters, and we're checking to see if everything in here actually is missed. So we're going to go into our board, and we're going to get the character, and if it's not equal to this underscore, then we can go ahead and delete that from mist, because that was a positive hit guess. That was one we wanted.
Okay, gotcha. Oh, okay.
And so what we can do with that is we can then go through dictionary again and say this.dictionary.filter, and we can filter out the word, where the word at I, we only want words where the word at I is equal to the character. Right? Every word in our dictionary at that I should be equal to the character, because that's what it has to be for it to be correct in the board. Kind of funny logic, but
Wait, is it word or words?
word.
Because we have words up there.
I would have called that word. I'll change it now.
Okay.
It won't matter, right? That's just like the writing the word L.
Okay.
Good catch, though. Okay, so we only want the words that have the correct character with the correct indice. Okay, so now we'll go outside of this for loop, and we can iterate through our missed elements. So we can say missed for each. And so for each character, we can filter again. So this dot words, oops, this dot dictionary is equal to this dot dictionary dot filter our word and we only want any words at all that include characters from our missed should not be in there, right? Because those were missed guesses.
Yes.
So we'll say, okay, so any word that includes the character should be filtered out. Close that. Okay. So I think we're pretty close.
You might need
Got it?
Mm-hmm.
Okay. So there's still a lot. This method's really ugly. So the next thing I want us to do is we want to create a count of every character so we can get the most common count. We want to get the most popular letter.
So vowel.
Well, not necessarily. Depends on what our words are. So we can iterate through our words and keep a count of everything. So that would look like let letters count. That's an empty object. And we can iterate, oops, we can iterate through our dictionary. That dictionary, that for each. And for each word, we can iterate through that word. So I'm going to say for let character of word. So this is going to give me each specific character in every word. And I'm going to say letter counts at character. So if it's in there, I'm going to go ahead and increment it by 1. Else, I'm going to do letter count at character and assign that to the value. Right, so that's just our classic counter method, essentially, that we've seen a lot. So now we got to actually figure out which is the most popular letter based off of that most popular value. So how do we do that?
We
have to do more loops. So I'm going to go ahead and say let max equals 0, so as if something counted no times. Let guess equal null. This will be the character that we're going to that we want to actually make our guess for. And then we'll say for let character in letter count. So this is how we iterate through an object. And then we can say, hey, if letter count at character, if that's greater than max, and this dot guessed, what do we call them? Guesses made dot has. So if we never guessed this character before, and it's greater than our current max, then we're going to say max is equal to letter count at character, and we're going to have our guess equal our character. So this is just going to help us determine the most popular letter of our entire dictionary. Okay. So then we actually have to make our guess. Right? So I'm going to say right now this quick little, I'm going to say like, what if there is no guess? What if we went through this whole thing again, like we just don't know what to do because we don't have that word, so we don't actually have that like letter, right? So it's like we went through this and our guess is still null. What can we do? So I'll say, okay, well, while it's null, which hopefully it's not, hopefully we have the word, right? We have our alphabet, we already saw that. So we'll do let rand, and I'll do math.floor, math.random, multiply that by our alf.length. Right, at the very top of this, it's a very ugly long function, but we still have alphabet at the very top. And we'll say character equal alf at rand, and then we should make sure that our guesses so far our guess is made doesn't have this. So we'll just say if this dot guess is made dot has this character already, then we should, or, well, if it doesn't have it, then we should update it. So we'll say guess equals our character. Otherwise, we don't want to actually Thank you. Otherwise, we don't want to actually update guess because we want it to keep running until we get a random one that we haven't already guessed. And then after this, we'll finally add it. So we'll say this dot guess is made dot add, and we'll go ahead and add our guess. And at the very end of this whole thing, we will return our guess. Okay, now we pray that it works.
Yeah, that was a long code.
Yeah, this should be cleaned up probably. But let's just go over it again from the top. So let's see if it makes sense to us. So we have our alphabet, dictionary. We're filtering our dictionary to only be words that are the appropriate length. We have our guesses made. This keeps track of every guess we've ever made. And we create a missed set that looks just like that. So like it recreates. It's like making a whole copy of guesses made. So we go, okay. Then we're iterating through our board, or our board's length, and it gets the character at the board, and it says, hey, if this character is not equal to an empty space, we will delete the character from our missed, because that means we've already guessed it. And then we're also going to filter every word from our dictionary that doesn't have the character at that I. It has to be every single one. So that's going to be really big. And then we're going to go through every missed character, and we're going to delete every thing from our dictionary that had that character, because that character was something that was missed. It shouldn't be ever in any words. Then we're keeping account of the occurrence of each letter of every single word in the entire dictionary. Then we're iterating to find out which letter appears the most of those remaining words. The letter that, if none does, we're going to randomly guess one. And then at the very end, once we've chosen our guess, we're going to add it to our guesses made, and we're going to return our guess. Questions on any of that? Okay, so let's try it. So let's go back to this being computer player. And my ref is going to be the human, and the guesser will be Robo. Let's choose a word that the computer actually has, yeah? So they have approval. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, well we can just run it from this screen. Okay, so we'll say node at game. Corey, enter the length of your word. Alright, so we decided that it's 8. Are we good with the word approval? Are we happy with that? Okay, so they guessed E. So approval has no E's. And then it guessed I. Approval has no I's. Interesting. O. So then it guessed O. So 1, 2, 3, 4, 5. So we'll say that it was the 5th letter. Please enter the position. Oh, A was guessed. So 1, 2, 3, 4, 5, 6, 7. So 1 and 7. Notice it's not drawing the board. We could have it draw the board for us if we wanted to, right? This would just be another like ref.draw board or display board. Okay, please enter the position of the character. Oh, so they guessed P. 1, 2, 3. And they guess R. I think they know the word. 1, 2, 3, 4. V was guessed. 1, 2, 3, 4, 5, 6. L was guessed. 1, 2, 3, 4, 5, 6, 7, 8. Robo wins. So they knew it was approval. See, we could change it to say like if it drew the board, we would have seen it. But we never had to draw the board. So we could add some stuff.
So why is it that it takes the number of the actual word instead of where the index
Oh, we could have done that. I did that to make it more user friendly.
Oh, okay.
Because I wouldn't expect a regular human to know what the indices are. I think most people would do it by the letter placement. That's a good question. So, yeah, so I guess where it says like this, that guess, or that display board, right? We could also say dot ref or something. Just so that we would also get to see what's going on.
In play, that's in play.
I'm surprised we didn't see the hangman pick. But now we run it again, or enter the length of your word. What word do we want to use? Hello?
Yeah.
HELLO 5. Okay, so now we can see it guessing. E was guessed. So 2. R was guessed. No R. L was guessed. Uh-oh. Oh, that's 3, 4. Sorry, I'm used to the clean indices. Oh, it thinks it's Jello? No. 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 Oh, maybe it doesn't have it. Oh. 1, 2, 3, 4, 5. No. 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 It has no idea. It might just get lucky, though. Oh, the game's not ending? Interesting. And now... So the game should have ended.
Yeah, because it even guessed the age. Oh, well, we just put.
Yes, the age plus, yeah.
But
Oh,
yeah, it should have stopped.
So we've got
after, like, B.
a bug. Let's figure this bug out. Are we up for it?
Yeah.
But this is weird that we're not seeing this picture every time. Or are we? Oh, maybe we are seeing it. It's not update. It's just not updating it. So we just need to have our so sometimes our positions.length is not coming back. So I'm gonna just say like if positions.length. Here, let's just see something. Because I think it's because we're not passing in an empty array. So
You're missing an I in positions.
thank you. Now we got some good spellers in this class. Okay, 5. Let's just like say you got it wrong. It's putting in this -1 when there's nothing there. So that's because of this. Where we're doing check guess, and it's 0, it's like coming back, there's nothing in there, it's doing a -1. So, with that in mind, I guess we could just do like, if return result at 0 is equal to a -1. So if it's a -1, we'll just return an empty array. Otherwise, we'll return our result. Now that we see what that's coming in as, does that change make sense? Okay. So then we can get rid of that. And now I think we can beat it.
Wait, can you got rid of,
Consonant oppositions.
okay, and then what did we said result equals to -1.
We're checking. We're just doing a quick turn error to check if we should be sending back an empty array or not.
Okay.
We'll see if we're right. So, well, it knows hello's right, so just say like 2. R is, there is no R. Let's make sure it's drawing correctly. Ah, this time it's updating. I guess L, so we'll say 3, 4. J is enter. If your word is hello, I like that it's the example. W is nothing. O is 5. I is nothing. H was guess, so they do guess H. Dang it. And Robo wins. Pretty smart game.
That's funny because he didn't guess it before. He waited like it was like all the way to 8.
Yeah,
all the way
maybe. I wonder if they have hello. We can check. Because they might not, and it might just be randomly guessing. They don't have it.
Oh, okay.
So because they don't have it, it's not a guaranteed win.
Can you add hello and see, like,
If it will guess it every time?
yeah.
Sure. It probably would have been here, right? Yeah. Oh, you're right. Like, it doesn't matter, right? These don't actually need to be in order, but we might as well because we're like here. All right, let's play again. 5 E, so that's 2. L is guess 3, 4. Was it learning? Jesus. 1, 5. Man, that's freakishly good. It's a super smart computer. Pretty cool, right?
Yeah.
So that's how you build a hangman game that does both parts. We could have the computer play the computer if we wanted to. All right, we could have it instead of this. We would just make this also a computer player. It can still be called Corey. Doesn't matter. But then the game will just play itself. Robo won that time. Robo's probably always going to win because Robo is the guesser, and the guesser here is genius, right?
Because the other one doesn't have the dictionary.
No, they're both the computer at this point, so they just are both looking at the same dictionary, and the guesser has the advantage. Oh, Corey actually won one. What was the word? So that's something we didn't include, right? When the game is over,
Reveal word.
yeah. So if this dot, yes, it is greater than 0, else we should say like, this dot ref dot reveal. It's just called reveal, right?
Yeah.
So we can say like, let winning word is equal to this, and we'll say like console.log word was winning word. This time. So now we'll know. If Corey ever wins again, we'll get to see what the word is. Road is going to win almost every time. Because they're both looking at the same dictionary. So I don't even know how Corey won. It must have been like...
A flute.
Yeah, it was a real... It's like 1 in 100. We'll never know what the word was. That's annoying. Oh well. The games get played really fast when it's a computer, right? Oh,
Corey just won.
okay, Corey won one. What did he win? How did he win? Word was term. Why would that not win? Let's go find out. It just must. There must be 6 more popular letters in the whole alphabet than these.
Well, usually when you play like Wheel of Fortune or whatever, you guess the vowels right.
Yeah.
All right. Well, let's see what happens.
And then usually most of it's taken up so you can use complicated
Yeah.
to figure out the other letters.
Well, so the human brain is still smarter than this game, sort of. Not really. Like if we know how to play better still. All right. So let's just try something. Let's say human player. Okay, our word is turn. Okay, Corey, enter the length of your word. 4. E was guess, so there's no E. U,
Oh.
no, I mean O, no O. A,
Okay,
no
yeah,
A,
the vowels first.
no I. So they do guess the vowel. They do get to it. It might just be too late because they've already missed 4 things. Now we say U. 1, 2. So there must be some other words that have the U in that place. Because like there's no L.
Like luck.
What?
Like luck.
Luck. Puck. Punt. Right? Like
Or puke.
right, those are all more. So it might have all of those. And so then they lose. Or they're going to soon. Yeah, so if I hit enter. Oh, it wants to know my word. Turn. Well, I don't know what the words are. We'd have to like. I don't know how to do a search for that. Turn. But I trust our program for the most part. Maybe it's famous last words. Pull and push. That explains the L's, 2 L's, and the P, 2 P's.
Mm-hmm.
That's all it takes. Ha! They'll never get turned. Boom! Unless we give them more words. But yeah. Any questions on this?
I guess it's just like going through it bit by bit and just knowing how to call it, like how to like this dot has its remaining or this dot or free dot name.
Yeah.
And going through it just time by time and then making sure you're calling on the right thing.
Right. I don't know what
I guess
that.
that just takes practice.
Yes.
Yeah.
Yeah. I'm gonna stop the recording.